So far, all of the annuity problems, both accumulation and liquidation, that we have looked at have involved where the investment time frame, referred to as the investment frequency, has been equivalent to the compounding. If we're paying in monthly, the compounding has been monthly. If we're paying in once a year, the compounding has been once a year. But sometimes that's not true. Sometimes the investment frequency and the compounding are not the same. So we're going to take a look at a couple of examples where they are different. So let's say, and we're just going to do some generics here. Let's say we're going to pay in $150 a month to an annuity that is 10% compounded quarterly. For 20 years. Now we're going to assume that this $150 a month is accumulated in some sort of a house account and then contributed at the end of the quarter when the compounding is scheduled to happen. Because if it was paid into the account every month, even though the interest is scheduled to be compounded quarterly, remember when we talked about U.S. rule for simple interest, every time there's an action, a payment or a withdrawal from an account, the interest has to be calculated. So if this $150 was put into the account every month, interest would have to be calculated anyway, and that would effectively make it compounded monthly. So then it would be no different than a regular annuity problems that we've looked at where they were compounded monthly. So we're going to say that this $150 times 3 months in a quarter is going to be $450 per quarter. So then this is simply an annuity formula. Our future value is going to equal that $450 payment times 1, 2, 3, 1 plus 0.10 for our 10%. That's quarterly now, so divided by 4 for quarterly. The power of 4 times our 20 years minus 1, close parentheses, divided by 10%, 0.10 divided by 4 again, close and close. So we get that at the end of that time frame, we would have $111,772.22. So $111,772.22 after 20 years. Well, let's look at the related problem to that. Rather than paying in monthly and the interest being compounded quarterly, we're going to pay in quarterly. We're going to make it an equivalent problem, so it's going to be $450 per quarter. Interest is going to be 10% compounded monthly. And it's still going to be for 20 years. This is actually a much more complex problem because the interest it's calculated every month, but the payments aren't made until each quarter. So there's 3 interest payments for every extra payment coming into the account. What we have to do here is we have to take this 10% compounded monthly and we have to convert it into an equivalent quarterly rate. And what we're going to do there is we're just going to go back to our compound interest, present and future value, and we're finding an effective rate for 1 quarter. In other words, for 3 months. So it doesn't matter what amount we use for the effective rate, remember. We're just going to pick a dollar amount that works well. So we're going to find the future value. We're going to use $10,000 because that helps our decimal places so we don't round off. Don't lose too much in a round off. Times 1 plus our 10%, so that's going to be 0.10, divided by 12 to the power of 12 months in a year, but to a quarter of a year. So that's only to 3 months. So 10,000 times, parentheses, 1 plus 0.10 divided by 12 for the monthly compounding. But I'm just going to put into the power of 3 here, because it's only 12 times 1 quarter is 3 months. So that'd be 10,252.09 would be the balance after that 1 quarter, or 3 months. We're going to subtract that beginning balance of 10,000 to get interest of $252.09. So now to find the effective rate, recall we're going to go back to that I equals PRT formula, where the 252.09 is our rate, actually our interest. Our principal is still the 10,000 that we started with. We are looking for our rate, and our time is again a quarter of a year. So we'll combine 10,000 times 1 quarter is 2,500 times R, and we're going to divide by the 2,500. So 252.09 divided by 2,500 gives us 0.10084 is our rate. Now we're going to convert that to a percent, 10.084%. And as we mentioned before, if we're not told where to round, we're going to round it to 2 decimal places, to 1/100 of a percent. So that's 10.08%. That is our effective rate for a quarter. So now what we're going to do is we're going to find our future value based on that $450 payment per quarter. 1 plus, instead of 10%, we're going to use 10.08% per quarter to the power of 4 times 20 minus 1 divided by 0.1008 divided by 4, close and close. So this 10% compounded monthly is equivalent to 10.08% compounded quarterly. Giving us a future value of $112,910.34. So now you'll notice the interest rate was the same, 10% for both. The amount contributed was the same. Up here, $150 a month is equivalent to $450 every 3 months or every quarter. But up here, since it was only compounded quarterly, you only had $111,772. Here, compounded monthly gave us $112,910. So those are ways to compensate if the frequency of investment is not equivalent to the compounding.